Here's the answers beginning with page 58, the oral exercises. We're asked to give an equivalent sentence. For number 1, we have x times x plus 3 equals to 0. This expression on the left side of the equation is in a particular format where there are two factors multiplied together, and the result is 0. For two factors to multiply together and the result ends up being 0, what must be true is that one of those factors has to be 0. That's a theorem that we studied in this section. The first factor is the letter x. The second factor is the x plus 3. One of those must be 0 so that when you multiply together you get an answer of 0. So let's express that. X must equal 0 or x plus 3 must equal 0. This is our equivalent sentence to this original one. For number 3, let's use the same technique. If two factors are multiplied together and the answer is 0, what must be true is that the first factor is 0 or the second factor is 0. That's the only way to multiply two things together and get an answer of 0. So let's write that down as a sentence. The 2t plus 5 has to equal to 0, or the t minus 7 has to equal to 0. For question 7, we're given a sentence and asked to write its converse. The converse of a sentence is created by exchanging the hypothesis and conclusion of the sentence. That is, by writing the sentence in opposite order. For number 7, our sentence is, if r equals s, then r plus t equals s plus t. This first portion, the part with the word if, is the hypothesis. The second portion, the part of it with the word then, is the conclusion of the sentence. To make the converse, we write a sentence that begins with the word if, but you switch the hypothesis and conclusion. Here it is in green. If r plus t equals s plus t, then r equals s. Notice what this sentence looks like compared to the original sentence given to us in number 7. The order of the information is switched. Question A asks, is our original sentence true? So let's go back to the original and decide if this is true. If r equals s, meaning if two numbers are equal, then can you add the same thing to both of those numbers and get a true equation? Yes, you can, because that's what the addition property of equality was all about that we've used this year, that it's okay to add the same number on both sides of an equation. So for question A, we're going to answer yes. Now question B, let's look at the converse and decide if it is true. If r plus t is equal to s plus t, then r is equal to s. Is that always true? Well, yes, it is, because of the subtraction property of equality. If we started with this equation, we could subtract the t from both sides to get r equals s. And it's okay to subtract the same thing from both sides. That's the subtraction property. So we would answer this question yes. Now question C, because the original sentence and the converse are both true, it's possible to write the sentence in what's called combined form. To use combined form, you use the conjunction if and only if in between the hypothesis and conclusion. So here it is in green ink. R is equal to S if and only if R plus T is equal to S plus T. If you ever see a sentence in math and in the middle of the sentence it has the phrase if and only if, that communicates to you that there are two if-then sentences that are true. First, if R equals S, then R plus T equals S plus T. And second, if R plus T equals S plus T, then R equals S. Number 11. Here's the original sentence. We're asked to give its converse. So we want to rewrite the sentence, still beginning with the word if, but switch where this piece and this piece are located in the sentence. It would look like this. If r times s is greater than 0, then r is greater than 0 and s is greater than 0. Question A, was the original sentence true? So if r is greater than 0, meaning if r is a positive number, and s is greater than 0, meaning s is positive, then when you multiply them together, you will get a number greater than 0. Does that sound true? A positive number times a positive number makes an answer greater than 0? Yeah, that's true. Question B, is the converse true? If r times s is greater than 0, which means positive, that is, if you multiply two things together and the answer is positive, does that mean that the r is greater than 0 and the s is greater than 0? No, that's not true. It's not true for all numbers, because if r was negative and s was negative, their product would be greater than 0, but both of the numbers themselves are not greater than 0. Because the original and the converse are not both true, you cannot write a combined form. Now page 59, the written problems. We're asked to solve an equation, and this equation has that form that we had just looked at in the oral exercises. There are two factors being multiplied together on the left side of the equation, and on the right it's a 0. Remember how we wrote this as an equivalent expression. We said that the first factor could equal 0, or the second factor could equal to 0. To finish this, we solve both of these equations. Let's focus on the first equation and add 10 to both sides. We get 5t equals 10. Therefore, t equals 2. Now focus on the second equation and subtract 24 from both sides. We get 4t equals negative 24. Then divide by 4, and we get t equals negative 6. Remember, the word or connects the two things together. So we want to put the word or in between those two results. We could make this a little bit neater by rewriting it underneath just to clarify that we have the two answers. Number 3, this is another equation where on one side of the equation there is a product of two factors, and the answer is equal to 0. Whenever you have that, you can rewrite it. Take the first factor and say equals 0, then write the word or. Take the second factor and set it equal to 0. Now solve both of these equations. The first equation is already solved for r. The r is already alone. The second equation we can solve by subtracting 210 from both sides. We get 7r equals negative 210. Then divide by 7. We get r equals negative 30. Remember, the word or connects these two results. I don't have enough room under here, so I'm going to go over on the side and write the answer. R equals 0 or r equals negative 30. Number 5 has the same pattern to it. It has a product, things being times together, and the answer is equal to 0. Whenever you have that situation, you can solve the equation by taking each factor and setting it equal to 0. So t equals 0, or 2t plus 1 equals 0, or 6t minus 48 equals 0. You can only use this technique when there is a 0 on one side of the equation. If there's any other number there, this will not work. Let's solve these individual equations that we've created. The first one is already solved, but in the middle one we can subtract 1. So we get 2t equals negative 1, and then divide by 2. We get t equals negative 1 over 2. Now the third one, let's add 48. So we have 6t equals 48, and then divide by 6. So t equals 8. Remember the word OR connects all these results together. Let's go over here on the side and write our answer. T could equal 0, or T could equal -1/2, or T could equal 8. If you used any one of those three choices in the original problem in number 5, and you substituted where the letter T is, when you work out the answer, it will equal 0. It'll check out. Okay, number 7. Look at the situation you have here. What do you notice about it? Does it fit the pattern that we've been practicing today? To solve this, take each factor and say that it's equal to 0. Take that middle factor and say that it equals 0. Take that third factor and say that it could equal 0. Now solve each of these. Add 3. We get 2p equals 3. And then divide by the 2. So we get p equals 3/2. Here in the middle, let's add 4 to both sides. And we get p equals 4. Over here on the end, let's first subtract 12. We get -4p equals -12. And then divide by the coefficient of -4. So we get p equals 3. Now let's put all these results together. P could equal 3/2, or P could equal 4, or P could equal 3. There are 3 possible solutions to this question. Now number 9. This has the same arrangement as the ones we've been doing. Don't let the fact that there's fractions in there bother you. Look for arrangements of things. Look for the basic patterns of things. So take the first factor and say that it equals 0. Take the second factor and say that it equals 0. Now solve each of these. For the first one, let's add 2 to both sides. And we get 1/x equals 2. Then multiply by the x. We get 1 equals 2 times x. Then divide by the 2, and we get 1/2 is equal to x. Now the second piece. Let's subtract 3 from both sides. We get 1/x equals -3. Now multiply by x. So we get 1 equals -3x. And then divide by -3. So we get 1/-3 is equal to x. The word OR connects these together. Let's go over here on the side and write the final answer. X could equal 1/2, or x could equal -1/3. For the review assignment, we're going back to page 55, and for number 2, we're given an absolute value inequality and asked to graph it. The technique is to rewrite this so it doesn't have absolute value bars. And there's 3 possibilities. We have problems that have greater than symbols like this. We have problems with equal symbols and problems with less than symbols. This one has a greater than symbol. So the rewriting technique is to take the y from inside the bars, to switch the arrow, and to switch the sign to a negative number. Then write the word OR. Take the y, keep the greater than arrow, and keep the +1. Let's graph this. Here's -1, and here's +1. Both of them get open dots because there's no or equal to bars on those arrows. Now the shading. Less than -1 would be to the left of it. Greater than +1 would be to the right of it. Now number 4. Another absolute value expression, this time with an equal symbol. So here's the rewriting technique. Take the 3 minus z from inside the bars and make it be equal to the negative of the 4. Then write the word OR. Write this again, but make it be equal to +4. Now let's solve both of these expressions till the letter z is alone. First subtract the 3. So we have -z equals -7. If negative z is negative 7, then when you solve for z, it's positive 7. Over here, when you subtract the 3, you get a 1. And when you change the sign to get z alone, you get negative 1. So on the graph, here's negative 1, and to the right of that would be positive 7. Both of these numbers get dots. Question 8 is an absolute value expression, so I'm looking to see which of the three situations it is. This one has the less than symbol. Here's how you rewrite it. You take the negative of the number on the right, and you put the less than symbol, and then write the 2 plus x from inside the bars, and put the less than again, and put the positive 1. It's the absolute value problems with the less than situation that creates this combined form where the letter x ends up in the center of the expression. Let's solve this by subtracting 2. We get negative 3 is less than x is less than negative 1. Here's the graph, negative 3 and negative 1, open dots on both. The letter x is in between the numbers, so shade everything in between. For page 51, we don't have any absolute values anymore. We do have what's called an inequality. There's an inequality symbol, not an equal symbol. But you do solve this just like an equation. Let's get the letter n alone on the left side. First, combine like terms. Over on the right side of the problem, I noticed the letter n appeared in more than one spot. Let's combine like terms. 1n subtract 5n is negative 4n. That transformation makes the problem a little bit shorter. Next, let's add 4n so that there's no n term on the right side. We get negative 14 plus 6n is less than the positive 7. Next, let's add 14. We get 6n is less than 21. Finally, let's divide by 6. We get n is less than 21 over 6. By the way, 21 over 6 is reducible because top and bottom both can be divided by 3. So this is better written as n is less than 7 halves. Here's 7 halves. It gets an open dot, and a less than symbol means to go to the left. Number 10, let's solve for d. I notice as I look across the entire problem that right in this area, the number 3 is being multiplied to the things in the parentheses. That reminds me of the distributive property. So that will be our first step. 3 times d is positive 3d. 3 times 2 is positive 6. The next thing I notice as I look across the entire problem and analyze it is the letter d is on both sides. We don't want that. So let's subtract the d so it's not on the right side. We get 6 plus 2d plus 6 is greater than 16. The next thing I notice as I'm analyzing the problem is on the left side there's a 6 and another 6. And 6 plus 6 is 12. So let's subtract 12 from both sides. We get 2d is greater than 4. Therefore, d is greater than 2. The graph has a 2 with an open dot and shading to the right. Now number 48. This time there is an equal symbol in there, so it's an equation, not an inequality. Let's solve. I notice as I analyze the entire problem that there's a 4 being multiplied to things in parentheses. That's distributive property. So 8 and then minus 40 plus 12y. It's plus 12y because in front of 4 is a negative sign. You're really going negative 4 times negative 3y. What's the next thing you notice as you analyze across the problem? You might notice that the 8 minus 40 can be combined into a single number. Or you might notice that the letter y is on both sides. What you choose to do might vary from what I choose to do. I'm going to combine like terms next. 8 minus 40 is negative 32. Then I'm going to subtract 4y from both sides and get negative 32 plus 8y equals 0. Then add 32 to both sides to get 8y equals 32. Therefore, y equals 4, because 8 times 4 makes 32. Number 30, as I analyze the equation, I notice a number being multiplied to parentheses, so I immediately think of doing the distributive property as my first step. We have 18 and then minus 5 over n. The negative 5 times the 2 makes negative 10, and that's equal to 2. On the left side, do you notice how the 18 minus 10 is really an 8? So I'm going to subtract 8 from both sides. 2 subtract 8 is negative 6. How can we get the n alone if it's in the denominator? It's going to be a two-step process. First, multiply by the n to move it to the other side of the equation. Then divide by the negative 6 so that the letter n is alone. Negative 5 divided by negative 6 makes positive 5 over 6. Finally, number 44. Solve the equation for the letter f by filling in numbers for all the other letters. For capital T, we're supposed to substitute 40. For M, we're going to fill in 10. For G, we're going to fill in 15. For M, we were filling in 10, and it's the letter F that we don't know a number for. Now let's solve this. The first thing we might do is simplify that 10 times 15 portion. That's 150. Next, we could subtract 150 from both sides. 40 subtract 150 is negative 110. Finally, we can divide by the negative 10 to get the letter F alone. Negative 110 divided by negative 10 makes positive 11.